Welcome. Okay, I thought I'd talk in a British accent to amuse myself because I'm by myself talking to a computer, and it's not very entertaining. It just sits there and, like a computer, it just sits there, do something. It's not doing anything. It just sits there, and looks back at me, bored apparently. So I have to talk in a British accent to make it different. Today I'm going to talk about arithmetic sequences and how we find the sum of arithmetic sequences. An arithmetic sequence, you can see an example right here. It has to do with hydrocarbons, organic compounds that contain only carbon and a hydrogen. So if you have one carbon atom, you're going to have four hydrogen atoms linked to it. Two carbons go with six, three with eight, four with 10. And we're going to look mostly at this sequence because this sequence here, I think you all understand it pretty well. And yes, moving on, the question becomes, how do we write a rule for for this? I mean, obviously, you could count 4, 6, 8, 10, 12, 14. You know what comes next, 16, 18, 20. But what if I wanted to be able to say, well, what goes after, what if carbon is 21, what goes here? I want to know the nth term, you know? Um, Here I just know the sixth term. I can figure out the seventh term by counting. So one way to do it is just, if I know the previous term, I can just add the common difference. And the common difference is just what's being added, and that's what defines an arithmetic sequence. So what I want to say is that, first of all, every arithmetic sequence has a common difference. And that's important vocabulary for these type of, oh, my accent is becoming Middle Eastern by accident. Common difference, NCE, and so the common difference here is 2. Yes? This common difference is 2. So arithmetic sequence, every term you add the same thing to it, and the difference between the terms is constant. So arithmetic sequences, this is an arithmetic sequence too. The common difference is 1. And an arithmetic sequence has a various starting point. But if we just go based on what came before, we can always just say that the next term is whatever the term before was plus the common difference. So that's one formula for common difference. If I want to find the nth term, so let's say the sequence is called A, and we want to find A to the n, or excuse me, A sub n, which means the nth term of the sequence A. So that's just some notation I'm using. It's nothing official. You don't need to memorize it. But this is A1, A sub 2, A sub 3, A sub 4, A sub 5, A sub 6. And so we could say that A sub n equals A sub n minus 1, so whatever the term was before, plus 2. Or more generally, beg your pardon, more generally we could say plus d, where d is the common difference, and that works for all arithmetic series or sequences. The nth term is the term before it plus d, the common difference. This is a recursive definition. A recursive definition is based on the term before it. So the problem with it is we need to know whatever the term before it is if we're going to use it. But what if I don't know the term before it? Like if I want to find the 21st term of the hydrocarbon sequence, I would need to know the 20th term, and I don't know the 20th term. I mean, this helps me come up with the 7th term. The 7th term is A sub 6, which is 14, plus 2. But the 21st term, I don't know what the 20th term is. I'd have to add a bunch of times. So we want a formula that doesn't use that term. We want a formula that just uses the starting term. We need one term. So if we could just use the starting term and come up with a formula that works like that. Now, the most enterprising amongst you will now stop the video, pause it, and come up with the formula yourself. And now you're back, and the formula for using based on the first term, a to the n equals a sub 1, the starting term, plus Well, how many d's? How many times do we add d? Well, if we're looking for the nth term, we've added d how many times? N minus 1 times. So this is a formula that tells me what the nth term is of an arithmetic sequence based on the starting term, the first term, and the common difference. And I'm not going to finish writing first because it's too annoying, the typing with my mouse. I wish you could see the way I'm trying to use my hands to draw. It's just it's a disaster. It's a tire fire. So, what else? What else to tell you about this? Using this formula, we should be able to figure out many different common differences. So what is the 21st term of this one? Well, what's the starting term? We need to know. It's 4, and the common difference is 2, and we're trying to find the 21st term. So we would say the 21st term would be 4 plus 2 times, we're trying to find the 21st term, so we're going to multiply by 20. And the 21st term is 44. 44. 44. Now, what else? There's some more examples here on this wonderful website. Let's turn off the answers so that it doesn't get ruined. You don't see them as soon as. Now, oh, these are problems where it says determine whether the sequence is arithmetic. So does it have a common difference or not? That's all that it does. Write a formula for a to the n plus 1. Well, a to the n plus 1 is a to the n plus d, right? Oh, that's a recursive one. And we would need so there's your recursive formula. This is what I was just telling you. The second formula I gave you based on the starting term is your explicit formula. And here's some examples. Let's say we need to find the 40th term when the starting term is 6 and the common difference is 3. You know, you may be pausing a video, you may be unpausing a video. The 40th term, starting term is 6, common difference is 3. And if we're trying to find the 40th term, that means we're going to add it. What a lovely parentheses that is. 39 times. 3 times 39 is 117, plus 6 is 123. So the 40th term would be 123. And so on. What if the problem might say, what is 315 is what term of the sequence? Of this sequence. The sequence that starts with 6 and has a common difference of 3. Which term is that? Well, so you have to work it backwards. So you go 6 plus 3 times n minus 1, and we're trying to find n now. Which term is it? Equals 315. Subtract the 6 from both sides, you get 309. Divide the 3 on both sides, you get 103. N minus 1 is 103. So 315 will be the 104th term. I'm writing on my own face there. What can I do? Do myself a mustache? No, I can't. Hello. All right. That's all on arithmetic sequences, I think. You can look at a few more problems here to practice yourself. And find the 30th term of this sequence. 37, 33, 29, 25. What's the catch? What's tricky new about this one? You have to figure out the common difference yourself. It's -4. It's negative. Find the 50th term when the first term is 7 and the common difference is -2. Find the 28th term. The first term is 3 and we go 7, 11, 15, 19. The common difference is 4. And so on. Okay? Enough about arithmetic sequences? I think so.